All right, y'all. Next up, here's what we got cracking. Building gates for the West Virginia Department of Natural Resources. We're doing 7 gates. They're fabricated out of pipe. I've got a picture I'll show you right here. So we got 6-inch pipe post here and here. Got a sleeve system right here that the gate's going to hinge on. Got 4-inch pipe running across the length of 14 foot with a 4-inch pipe gusset. Got a 6-inch pipe right here as a padlock protector. So there's going to be a bar welded to that piece right there. Goes through the 4-inch pipe through a cap in that. And then your padlock would be inside that 6-inch pipe where it's protected from being hit or cut. Got pipe being delivered here today. The supplier that's bringing that pipe was missing one piece of pipe that I was needing. And I found it yesterday from another supplier. So since it was just that one piece of pipe, I went and got it. I jumped in the super service area yesterday, jumped in the super service truck, rolled that way, throwed that piece of pipe on the overhead rack, strapped her down, and hauled her back. So I got it right here. And like I say, the other pipe for this is set to be delivered on truck today. Well, any of you that aren't real familiar with how these H&M saddle type pipe cutting machines operate, you're in for a treat because you're going to see. This saddle section right here is what sets on the pipe. And the reason one of these machines can cut pipe from 2-inch to 8-inch, well, it's because of changing this spacing. Now these spacers right here, these are called cuboids. Cuboid spacers. It even says on the machine, cuboid spacers required. Well, what this does is, depending on how you turn this spacer, it changes the thickness of the spacer. And if you look at the spacer real close, there's a number on it. That's got a number 4. That means if you're cutting 4-inch pipe and you put this under the machine so that that side of the spacer makes contact with the pipe, then you've got the right cuboid in place for that size pipe. And if you're really confused about how this operates, just stay tuned because I'm going to show you. So by cutting out that piece of pipe and welding a flat bar across it and burning a hole in it, I've made another pattern. So we'll do another test cut on this piece of scrap and see what size plate we end up with. I don't expect it's going to cut very good when it gets over here where this piece is welded on. But it'll probably be good enough to see what kind of a plate this pattern's going to cut. I'm really happy with the looks of that cap. That's fitting on that pipe just the way I wanted it to. And even though this thing's spliced together and goofed up, we won't be using it, but using it as a test piece cut out of that scrap to hold up here and make sure we got what we want. Now we're good to go. That right there is the pattern I used to make the cap the way I wanted it. Just a plain plate cap with pretty much like a 6 11/16 outside diameter for my 6 5/8 OD pipe. Now, there's another pattern that I need, and it's going to be a pattern that cuts a ring, pretty much a ring. And when I say ring, what I'm talking about is we'd have a plate with a hole in it, and this hole, inside diameter of the hole right here, is going to be about 5.5 inches, maybe 5 5/8. And then this outside would be a cap for a 6-inch pipe at our 6 5/8, 6 11/16. Now, this pattern, if I follow the outside and then follow the inside, it doesn't make what I want. I tried that right here on this piece, and if I use this piece, I used this piece as a test to see if it would fit like I was wanting it to, and it's way too big on my inner sleeve pipe. What I'm wanting is a ring, a symmetrical one, with a hole in the center that will match my inner sleeve pipe, but an OD of that ring that'll match that 6-inch post. Now, even though I used that 6-inch pipe and made my OD and it doesn't work to make the ID, this pipe right here has the same OD but a smaller ID. This is a Schedule 80. That one over there is a Schedule 40. So I'm going to make this pattern out of this and see if it'll do what I need to do. So let me bring you up to speed on why we made that pattern and why that pattern cuts out a ring like this. Now, on our post that has the hinge for the gate, we have an inner sleeve like this, and then we have an outer sleeve like this. The inner sleeve would be connected to the pipe that goes in the ground and cemented in place. That's stationary, it doesn't move. This outer sleeve is going to spin around this one, allowing the gate to hinge. That's where your hinge action is going to come from. but we need a cap on it, and it's going to fit pretty tight like that. But this kind of a ring allows us to weld this onto that stationary pipe. This can still hinge around it. Then I can take a regular disc cap like we burned out earlier, put it over that and weld it to this plate. So it'll cap the pipe, allow it to turn, and seal weld around this so that water can't get in the pipe in any way. So real quick, I'm going to try and show you this just a little bit better. We've got our inner sleeve pipe, outer sleeve pipe rotates around it. That makes up our hinge. There's a little gap right here, and that's going to be shimmed up. There'll be shim material in between the two of them that allows this to be tight, but not so tight it doesn't move freely. Now for our caps, we've got to have this ring, and this ring, it's going to weld onto that inner pipe. This is going to allow us to weld that inner sleeve pipe to this ring, and then take our cap and weld the cap right onto the ring. That caps off that inner sleeve pipe so that water can't go in it, while still allowing this outer sleeve pipe to turn. So we'll look at that some more later. This is going to be it for part one. We've got some pipes cut. We got some parts made. So thanks for watching, and stay tuned for part two.